So now we'll be solving few questions based on the concept that we learned. We are given a non-pipeline system that is taking 75 nanosecond to process a task. The same task which can be processed in a 6-segment pipeline with a clock cycle of 15 nanosecond. So first thing which is given, the Tn which is 75 nanoseconds and Pp which is 15 nanoseconds. This is for non-pipeline, this is for pipeline. And the segments, there are six segments, and for the first part of the question we are given 100 tasks and equals 100. So determine the speed up ratio of the pipeline for 100 tasks. We know that the speed up ratio S will be equal to n, the number of tasks, into Tn divided by k plus n minus 1 into Tp, where k is the number of segment and Tp is the cycle time for pipeline. We'll put all these data in 100, then 75 as Tn, 6 segments, 100 tasks and minus 1 into 15, which is the Tp. We'll solve it, we'll get 4.76. This is the speed up ratio. Now what is the maximum speed up which can be achieved? So we have discussed that a speed up ratio, or the ideal speed up ratio, or the maximum speed up ratio. Here we will consider k minus 1 is very less than n, so this can be neglected as 0. We'll put k minus 1 as 0. We'll be getting n into Tn divided by n into Tp. N gets cancelled out. We are left with S maximum equals to Tn by Tp, where here we'll put the data Tn and Tp. 75 is Tn and 15 is Tp. We'll get final answer as 5. Now we are given another question. This is consider a 5-stage pipeline with a cycle time of 2 nanoseconds. Calculate the processing time of pipeline for 200 tasks. So what are the things that are given? 5 stages means there are 5 segments, n equals 200 tasks, and the cycle time of pipeline. This is a pipeline case, so Tp equals 2 nanoseconds. So the formula that we will be applying for the total time, which is k plus n minus 1 into Tp. Here k is the number of segments, n is the number of tasks, and Tp is the cycle time. This is the formula. We'll put the data here, 5 200 minus 1, and multiply it with 20, the cycle time. We'll get the final answer as 4080 nanoseconds. This is another question where we are given 6 segments. This is a pipeline with segment delay of these are the segment delays 10, 16, 11, 12, 14 and 14 nanoseconds. So we have to calculate the processing time of pipeline for 1000 tasks. So first thing, which is k segments, the number of segments is 6, the number of tasks is 1000. Now in order to find the cycle time, we have to find out the maximum segment delay out of these. So we can see that 16 is the maximum among all these data, and we are not given with any kind of register or buffer delay, so we'll assume it to be 0. So the final answer will be 16 nanoseconds. So in order to find the total time, processing time, we'll use this formula, k plus n minus 1 into Tp. K is 6, n is 1000 and Tp is 16. So we'll multiply these and the final answer will be 16,080 nanoseconds. So here is another question where 6 segments pipeline is given with segment delay of, again these are the multiple segment delays which are given, and we have to calculate the speed up of pipeline when compared to a non-pipeline system. The number of inputs is 200. So given data, 6 segments, 200 tasks or the 200 inputs. In order to find the clock time, the clock cycle time for this pipeline Tp, we have to find the maximum of all these. So the maximum is 22, and again we are not given with any register or buffer delay. We'll consider it as 0. Now for non-pipeline, we can do nothing but to add up all these things, and this will come out to be 130 nanoseconds. We are asked for the speed up ratio, and the formula for speed up ratio is this. We'll put the data, n is 200 and the Tn is 113. 205 is coming from this calculation. K equals 6, n equals 200, and this minus 1 will get it as 205, and this Tp will put 22, which we have calculated here. The final answer will be 5.011. Here we are given similar kind of question. It might look complicated because of this diagram, but it is a very simple question. It says that instruction pipeline of 4 stages, k equals 4. These are the segments, and each of these each with combinational circuit only. The pipeline registers are required between each stage. This means we are using these buffers. These are the buffers. Now we can see that this state S1, this is having delay of 5 nanoseconds, this is having 6 nanoseconds, 11 and 8, and each of the registers are having 1 nanosecond of delay. Now we have to find the approximate speed up under ideal condition. So in order to find the speed up in ideal condition, we need to find the cycle time for non-pipeline and for pipeline. For non-pipeline, we'll add up all the segment delays, and for pipeline we'll find the maximum of the segment delays and add up this register or buffer delay, which will be 12 nanoseconds. Now for speed up, the ideal speed up will be Tn by Tp, which will be 2.5.